Okay, when we are determining which significant figures are, or which figures in a measurement are significant, rather, um, every non-zero digit in a reported measurement is going to be assumed to be significant. So in these three examples in 24.7, the 2, the 4, and the 7, all three are considered to be significant. In the 0.743, the 7, the 4, and the 3 are considered to be significant. And then in 714 meters, the 7, the 1, and the 4 are considered to be significant. Now, when we see a zero between two non-zero digits, they are always considered to be significant. So those are often called trapped zeros. So in 7003, the 7, the 0, the 0, and the 3 are all considered to be significant. The 40.79, so 40.79, all four of those digits are considered to be significant. And then 1.503, the 1, the 5, the 0, and the 3, all four are considered to be a significant digit. Then leftmost zeros appearing in front of non-zero digits are not significant. They are considered as just a placeholder because you could write the number in scientific notation and eliminate the zeros. 0.0071 could be written as 7.1 times 10 to the negative 3 meter. We could take this decimal and move it 3 places to the left, and in that case we would only have 2 significant figures. Right here we could move the decimal 1 place to the left and write it as 4.2 times 10 to the negative 1. Therefore, it would only have 2 significant figures. We could move this decimal 1, 2, 3, 4, 5 places to the right, and that would eliminate all these zeros, and we could write it as 9.9 times 10 to the negative 5, and we would only have, again, 2 significant figures. In the same manner, if we have a number and we've got a decimal point, if there's a decimal there, it's considered to be all these zeros are significant. If there were no decimal here, 9000, we could express it as 9 times 10 to the third meters, and it would only have 1 significant figure. But because there's a decimal right here after the 9, this has 4 significant digits. 1.010 has 4 significant digits, and 43.00 has 4 significant digits. If there is a decimal and then zeros follow the decimal, they are considered to be significant figures. Zeros at the rightmost end of a measurement that lie to the left of an understood decimal are not significant. So in this case, 300, it's understood that the decimal is right here. We could move that 2 places to the left and write it as 3 times 10 to the second power, so it only has 1 significant figure. We can, again, it's understood to be at the end of the number. We could write this as 7 times 10 to the third power, and this is understood to be a decimal right here. We could write it as 2.721 times 10 to the fourth power. If zeros were known measured values, then they're always significant. There are two situations in which numbers have an unlimited number of significant figures. If they are counting, a number that is counted is always an exact number. So if we count how many people are in our classroom, if we count how many pennies are in a jar, if we are counting values, it's always significant. And the other one is a quantity in a system of measurements. So we know that there's 60 minutes in an hour or 100 centimeters in a meter. So that has an unlimited number of significant figures.